Hello, good day everyone, and welcome back to the channel Master Mariner Amit Sangwan. Basically, in this video, we are going to see how to do oil tanker calculations. So basically, this video will be useful for junior officers, cadets, third officers, second officers. Chief officers are already aware of this, they know this, but then nevertheless, they can use it for the revision. So basically, when you are keeping watch in the cargo control room, you see the mate calculating cargo figures and all. So it will basically help you to understand that how to go about doing this cargo calculations. Also, it will help you in your exams and when you go for promotional interviews. This might help you there also. So watch this video carefully. Now we will start with certain some definitions. Basically, we will not read these definitions word by word or something. We're not going to ratify it. Basically, it is to understand. The whole purpose of this video is so that I can help you understand how these calculations are done. Now, before I start this, let's take any example of certain liquid in a cargo tank. For example, if you want to calculate the quantity of cargo in a particular tank, at the present moment, all of you know there are something called as the ullage tables or the sounding tables. You take the ullage of that particular cargo tank, you enter the ullage tables, and you will get a volume. Now that volume what you get is at a current temperature, or what is the volume is at basically at the present temperature. So at load port, it may be possible that a current temperature is different of that particular cargo. When you go at the discharge port, the temperature will be different. So if you calculate one volume at the load port and you go and check the volume at the discharge port, that volume will be different because that temperature will be different. So for that purpose, so that we can make a comparison of the volume at load port and at the discharge port, there is something known as a standard volume. Basically, that is volume which is calculated at 15 degrees Celsius or 60 degree Fahrenheit, and that volume is called as the gross standard volume. And that GSV or gross standard volume is used to make comparisons because that is at a standard temperature. Anyways, let's start with this first. First, what we are going to say is the total observed volume. And what is this total observed volume? That this total observed volume of all petroleum liquids and free water at an observed temperature. Suppose you take a particular cargo tank, you take the ullage, you go to ullage tables, and you take the total volume. This becomes your total observed volume, right? Which is also known as TOV. Then we have the gross observed volume. That gross observed volume is equal to total observed volume minus the volume of free water inside the tank. When you see the total observed volume, it is basically at present temperature, the total volume, the total contents of that cargo tank is total volume. But if you minus the fresh free water, then that will give you gross observed volume. Okay, so you have TOV, which is the total volume. You have the GOV, gross observed volume, that is the TOV minus the volume of free water. This free water can be zero or there can be some water. Now, normally in products, you will not find any water. On refined products like gas oil, gasoline, or naphtha and all, you will not find any water basically. But if you see crudes, there are certain crudes where there may be a large amount of water, particularly in if you load in Basra and all, this Basra light and Arabian light crudes are known to have a lot of water, free water in along with this crude. So when you subtract the total quantity of total volume of free water from your total observed volume, you get the gross observed volume. Then we have the gross standard volume. Now this TOV and GOV are basically at the current temperature. The moment when you are taking the ullage, that time what is the temperature inside the tank of that cargo, that gives you that gross observed volume. There is something called as a gross standard volume. Now we need to convert this volume at observed temperature to volume at standard temperature. So the volume what we get at the standard temperature, that the volume what we get at 15 degrees Celsius or 16 degree Fahrenheit is what is called as the gross standard volume. And this gross standard volume is equal to gross observed volume into volume correction factor. So gross observed volume, you have taken the ullage. From the ullage, you've got the total observed volume. You have subtracted volume of free water. What you get is gross observed volume. That you multiply by the volume correction factor, VCF. How we get that VCF? VCF we get by using the ASTM tables. We will see what these ASTM tables are, but VCF is volume correction factor. Basically, from observed temperature to 15 degrees Celsius or 16 degree Fahrenheit, we are going to reduce this volume. Okay, so we are going to multiply this volume correction factor, or sometimes also called as volume reduction factor, and for that we use the ASTM tables. Now I'll tell you, there are many ASTM tables available on board the ship, but basically on oil tankers you're going to use a series of table 6 and table 54. So if you are on a crude oil tanker, basically you are going to use tables A. If you are going on a product tanker, you are going to basically use table B. And if API is given to you, you are going to use table 6, and if density is given to you, you are going to use table 54. So basically, let's assume you are being given a crude oil, so you're going to use A, and you're given API, so basically you are going to table 6, so that makes it table 6A. So you go to table 6A. From there you will get the volume correction factor, or if it is a product, then you may use table 54B. B is basically we are going to use for products, and 54 is when you are being given density. That time you're going to use table 54. Now what I'll show you here is basically I'll show you an example of ASTM tables. Now this is an example of table 54B. So if your temperature is at 34 degrees Celsius, current temperature is 34 degrees Celsius, and your density is 0.816, then your volume correction factor VCF will be 0.9830. If you multiply your gross observed volume by 0.9830, that will give you your GSV, or the gross standard volume. So this is an example of table 54B, where temperature, you have taken from the tanks using your MMC or UTI, you have seen the temperature, and then from this density at 15 degrees Celsius, this is given to you by your charterers or by the surveyor or anybody. It will be provided to you. From that you can calculate the volume correction factor, and from that you can get your gross standard volume. Okay, now I'll show you the next part. So you have got your gross standard volume, that is GOV into VCF. We have seen how to calculate the VCF. VCF, nowadays you have some programs also, ASTM table programs. You can use those ASTM table programs, or else you should manually know how to calculate this VCF, how to get this VCF. Free water, how you're going to calculate it? Basically the volume of water present in a tank which is not in suspension in the contained liquid at observed temperature. So basically you're going to use your UTI, and with the help of that, you're going to calculate the sounding of this free water. Then you're going to enter your ullage tables. You are either going to use the sounding, or you're going to change that sounding to ullage, and you are going to calculate the volume of this free water. All right. Onboard quantity, OBQ. What is OBQ? Basically, this is the quantity of water, oil, slopes, residue, sludge or sediment remaining in the tanks prior to loading. So basically, when you go at the load port, the surveyor will carry out a survey along with one of the duty officers or the cargo officer, and the quantity which is there inside the tanks before you load is known as OBQ. One is OBQ. Second thing which is there is the ROB, remaining on board. That is basically once you have finished discharging, then you're going to go for a survey of the tanks, and that time if you find any sludge or anything remaining at the bottom of the tanks, that remaining quantity is known as ROB, remaining on board. Right now we are not interested in remaining on board, we are interested in on board quantity, that is OBQ. That is the quantity which you have inside the tank before you commence loading. So that total calculated volume, this is basically your gross standard volume plus your free water. Okay, so from here you have calculated your gross standard volume, that is gross observed volume into VCF. Now this gross standard volume plus you add your volume of free water, that gives your total calculated volume. All right, this is your total calculated volume. Total received volume is basically the volume what you are going to receive at the load port. So you have your total calculated volume minus the OBQ, the onboard quantity what you had, will give you total received volume. Now what we have received here, or what we have calculated here, is volume. You have the total observed volume, you take an ullage from ullage tables, you have subtracted the volume of free water from it, you have got gross observed volume. That gross observed volume you have converted into gross standard volume by multiplying it by volume correction factor. So you've got gross standard volume. The gross standard volume plus the volume of free water, you get total calculated volume, and the total calculated volume, you get the total received volume by subtracting OBQ from it. So you have total received volume. This total received volume, if you multiply it by the weight correction factor WCF, will give you the loaded oil weight. So for that you can use this. That while using these ASTM tables, what you can do is, so you have on this particular example, it is in barrels, you can convert into cubics also. So 1 cubic is equal to 6.28981 barrels. So you can use cubics or you can use barrels. So basically you have volume at observed temperature, then you are going to use VCF to convert this volume at standard temperature of 60 degrees Fahrenheit. For that you're going to use either table 6A or 6B. That means if B is there, B is basically used for products, A is used for basically crude oil. Table 6 is basically when API is given, and if density is given, then you would have used table 54. So you can select 6A, 6B, 54A, 54B, depending upon what is given to you. You will get the VCF, and after multiplying your observed volume by VCF, you will get a standard volume. Now, once you get the standard volume, you're going to use weight correction factor from table 13, ASTM table 13, you will get weight in metric tons. If you need weight in short tons, you're going to use ASTM table 9. From there, you will get weight correction factor. If you need in long tons, you're going to use ASTM table 11. From there, you're going to get weight correction factor. So this standard volume, you can change it to weight in metric tons, or weight in short tons, or weight in long tons as you require it. So this is how you are going to calculate your quantity of cargo. This is simple calculation now. So loaded oil weight is equal to the gross standard volume minus OBQ, and a weight correction factor is applied to this volume to obtain weight in metric tons or long tons or short tons. So loaded oil weight is equal to GSV minus OBQ into WCF, and WCF you can get it from table 13 or table 9 or table 11, depending upon in whether you want it in metric tons or long tons or short tons. Okay, so this is how you're going to calculate this cargo. Simple calculations. There's something about vessel experience factor, which briefly I will tell you about that also. That over a period of time, when you load cargo in a ship, you will find that when you compare the ship's figures to the shore figures, there is a small amount of difference into the figures. If the shore is giving you, let's say, 10 cubics, it is quite possible that you are not receiving 10 cubics all the time. Either you will be receiving 9.9 or you may be receiving 10.1. That is because there may be a difference in calibration of your tanks with your ullage tables, and over a period of time, what is done is over 10 voyages or over 20 voyages, an average is being calculated. That is basically to see the vessel's experience factor. That is, with that average of 20 voyages or with that average of 10 voyages, it is seen that is that the normal scenario in the ship, that every time the shore is giving you 10 cubics, you are receiving 9.1 or you are receiving 10.1. So that is the vessel's experience. It may be possible at load port when the shore is saying, okay, we have discharged 9.1. When you calculate on the ship, you will find it, okay, correction. If the shore says that we have discharged 10 cubes, you say I have received 9.1. And when you go at the discharge port again, they are receiving 10. But when you calculate it on the ship, you will get it 9.1. So over a period of time, for about 10 or 20 voyages, that normal average is taken to see the vessel's experience. And that factor which is calculated becomes the vessel experience factor. Okay. That is because there is the tanks are not exactly rectangular or square in shape, and to calculate the volume is not very easy. So those ullage tables are basically calibrated to calculate this volume. All right. So this vessel experience factor is equal to the total of gross bill of lading figures divided by the total of ships figures over the last 10 voyages. For the purpose of calculating vessel experience factor, 10 to 20 voyages may be taken. However, all voyages must qualify. A minimum of 5 qualified voyages is needed for some level of vessel experience factor. And the definition of a qualified voyage is one that meets the following criteria: that any voyage that is within plus minus 0.003 of then average ratio of all voyages listed. Example, if the average listed is 1.00105, then all voyages within the range 0.99805 through 1.00405 would qualify. Excludes all voyages prior to any structural modifications which affected the vessel's cargo capacity. Excludes load or discharge data where shore measurements were not available. This factor is not to be applied to ship's figure for assessing ship-shore difference. The factor may be applied to ship's figures to obtain an approximate bill of lading figure only as a counter check, and ship's figure into vessel experience factor gives an approximate bill of lading figure. That is why the bill of lading figure is always calculated, always based on the shore figures. It is never based on the ship's figures. But there are certain ports where the bill of lading is based on the ship's figure. That time basically it is the ship's figure multiplied the vessel experience factor gives you an approximate bill of lading figures. But these figures what you get are not going to form a part of, this is not going to form a part of your qualified voyages. So we'll see about API and ASTM tables. Basically API is American Petroleum Index, full form of API is American Petroleum Index, and ASTM stands for American Standard of Testing Materials. Previously, there were 3 versions of these ASTM tables. That was a USA version, UK version, and metric versions. Okay, now all of them are combined together. So a quick revision of what we have seen in practice, what we actually do. That is, volume at observed temperature is calculated by taking ullages. That means if you want to calculate volume now, you take the ullage of the tank, okay, assuming that the ship is at even keel, because if it is not at even keel, if there is a trim and if there is list, then you will have to apply trim correction and list corrections also. Now, for example, the ship is at even keel. So you are going to take the ullage at the observed temperature. So you know the present volume now, observed volume. The density at 15 degrees Celsius is given by the shore authorities. So the volume at 15 degrees Celsius is equal to volume at observed temperature into VCF. We have seen how to calculate the VCF. And volume at 15 degrees Celsius into density at 15 degrees Celsius will give you weight at 15 degrees Celsius. And weight at 15 degrees Celsius is also known as in vacuum. Okay, but we want weight in air because this is how we calculate it. And for getting weight in air, we basically subtract 0.0011 from density at 15 degrees Celsius. So density at 15 degrees Celsius is given to you by the shore authorities, minus 0.0011 will give you weight correction factor. GSV multiplied by weight correction factor will give you weight in metric tons in air. This is basically for when you are calculating products. When you are calculating crudes, I showed you a diagram earlier where you're going to use different weight correction factor tables, different ASTM tables for getting WCF, that is table 11, 9, and table 13. Okay. So now all the 3 versions of this ASTM tables are combined together and made into 14 volumes, which contain all calculations regarding crude oil, lube oil, diesel oil, and all kinds of fluids or liquids. A particular ship may have selected volumes only for the trade on which she is being run. You may have this hydrometer on board the ship to measure density of water. You may have pycnometer, that is to measure density of any liquid other than water. So this is basically how you calculate volumes on a oil tanker, which is basically very simple, and I've tried to explain you it in a very simple manner. Now, this is for understanding the principle. The next what I will show you is, this is something called as the ullage sheet. Okay, the or ullage sheet or ullage report. And basically we have to learn this calculation so that we are able to prepare this ullage sheet, so we can calculate a total quantity of cargo. For example, let's say one port. What you're going to do is, or okay, we will quickly familiarize with this ullage sheet. Here you're going to write basically tank number, the grade. Okay, so let's assume tank one port. What is the grade? You can put any grade here, whether it is crude oil, whether product, whatever is the grade, you're going to put that grade here. Then ullage what you read it from your MMC, you put that ullage. Then if you have any fresh water, any free water, so if you have any free water, that is always written in sounding, whether 1 centimeter, 2 centimeter, 3 centimeter, you can put that centimeters here. Temperature, you're going to take the temperature from the tank. All right. Then total observed volume. Basically, total observed volume is the total volume at present temperature. So this you're going to get from the ullage tables. So with this ullage, you enter the ullage tables, you will get the total observed volume. With this sounding, you're going to enter the ullage tables, you will get the volume of free water. This volume minus this volume will give you gross observed volume. Then you're going to enter the ASTM tables. Now it depends whether it is crude oil, whether it is product. For example, this is crude oil. So for crude oil, we are going to use table A. And then when in this particular calculations, we are being given API. So we are going to use table 6A. For example, if density was given, then we are going to use table 54A. So for crude, you're going to use table A. For product, you're going to use table B. If API is given, you're going to use table 6. If density is given, you're going to use table 54. For in this case, crude is given, so table A plus API is given, so table 6A. So then we are going to enter table 6A. When you enter table 6A, you will enter with the temperature and API. Okay, with temperature for this, the API is 43 and temperature is 76.1. So with this temperature and with this API, when you enter, you will find VCF is 0.9917. You multiply a gross observed volume by VCF, you will get your standard volume as this. So you will get your standard volume. Then we want metric tons in air. So that for that, you're going to use a table 13. Then with this figure, when you're going to enter table 13, you will get a weight correction factor. You will multiply your GSV by weight correction factor, you will get weight in metric tons. For all the tanks, you're going to proceed in the same manner. At the end, you will get the total weight in metric tons. You will get the total gross standard volume, total gross observed volume, average temperature and everything. This is you can do manually. This sheet, particularly on all the ships, you will find basically it is programmed. All you have to do is you have to write this TOV and this free water volume. Rest everything is automatically calculated, but nevertheless you should understand and you should know how to manually calculate it if there is some problem with the programming of the sheet. Okay, so now if you go to the bottom section of this, you found total observed volume is this much, free water is this much, total observed volume minus free water gives you gross observed volume is this much. From the gross observed volume, you will get your gross standard volume is this much. Gross standard volume plus your free water, you will get the total calculated volume. Then you minus this OBQ, you will get the total received volume. So your total received volume is this. This is in barrels, this is in cubics. All you have to do is you can calculate barrels into cubics. Okay, your barrels divided by 6.28981 will give you cubics. So you've received in barrels, you've received in cubics. Okay, so you've got your total calculated volume, that is in barrels. The same you can multiply by weight correction factor and you will get in metric tons, you will get in long tons, you will get in cubics. And you have the VF, which is 0.9982, which is calculated over an average of 20 or 10 voyages. And you will get your, you will divide this total corrected volume by VF, and you will get your figure after applying VF. So this figure is used for comparison with the shore figures after applying VF. So basically, gentlemen, this is how we make calculations on a tanker. I hope you have understood the basics of this cargo calculations. If you have any questions or any doubts, you can put in the comment section. I will try to give a clarification, or I will try to explain those doubts. Okay, gentlemen, I thank you for watching this video. And if you find it useful, and if you think that with this you have got some information or got some knowledge or at least some idea or whatever, if even if this video has helped you in a small manner, then please subscribe this channel and share this video with your friends or all tanker guys, basically who are at junior ranks, and it will help them when they go on a ship, when they are doing cargo watches there, it will help them to understand this. Okay, gentlemen, thank you for watching this video. Thanks a lot. Please do share and subscribe the channel, and share it with your friends. Thank you. Thank you. Thanks a lot.